Welcome to another deep dive. Today, we're taking a look at number theory, algorithms, and a dash of Python programming. And, you brought this to us, this really interesting problem from Project Euler. And
Yeah,
it seems deceptively simple, but I have a feeling it's got some hidden depths.
it certainly does. Project Euler problems are known for that. They
Yeah.
seem simple on the surface, but there's a lot going on underneath. This one's a classic example of how a little bit of number theory combined with some clever coding can give you really elegant solutions.
Okay, so before we get into the how, let's talk about the what. What exactly is this Project Euler problem asking us to do?
Right, so the problem says find the sum of all the natural numbers below 1,000 that are multiples of 3 or 5.
Okay, so 3, 5, 6, 9, so on and so forth. So it seems simple enough on the surface, you could probably do it on a napkin, right?
You could. For smaller numbers, absolutely. But imagine if you had to do this with like a million numbers, a billion numbers. That's where algorithms come in. And that's what we're going to explore today, how to design a program using Python to solve this problem efficiently.
All right, so we've got our problem, we've got our tools, let's dive into this. So how do we start translating this math problem into something a computer can understand, something we can code?
Okay, so think of Python as our coding translator, right? And Python's awesome because it gives us options. One way is brute force, basically tell Python to check every single number below 1,000.
Yep.
If it's divisible by 3 or 5, add it to the sum.
Okay, that makes sense, but it also sounds a little inefficient, right? Like we're taking the long way around.
Exactly. It works, but it's like taking the scenic route when we could be on the Autobahn. And this is where number theory comes in to speed things up.
Okay, I'm always up for the Autobahn.
Yeah.
So what's the faster route in this case?
Arithmetic progressions. See multiples of 3, 3, 6, 9, and so on, or multiples of 5, 5, 10, 15. They form these predictable sequences. And the cool part, there's a formula to directly calculate the sum of an arithmetic progression.
Hold on. Are you saying we can just use this formula to get the sum of all the multiples of 3, do the same for the multiples of 5, add them together, and we're done?
You're getting close. You're on the right track. But gotta watch out for the speed traps. We've double counted the numbers that are multiples of both 3 and 5, like 15, 30, and so on.
Sneaky. So we got to get rid of those duplicates before we declare victory.
Exactly. You got it. Subtract the sum of multiples of 15, 3 by 5, and you're good to go.
So we use a bit of number theory magic, we sidestep the brute force, we dodge the double counting trap, and boom, we've got our answer. But how do we actually write this in Python?
This is where Python really shines. It has these built-in math functions that make this super easy. We use range to represent those sequences of multiples, sum to add them up, it's right there in the name, and a touch of modulo operator, the percent sign, to figure out if a number is divisible by 3, 5, or 15.
And the best part, it's way, way faster than writing everything out by hand, right?
Absolutely. And here's the thing. This approach, it's not just for 3 and 5. You can use it with any set of numbers. Tweak it a little, and you're good to go. It's all about recognizing the patterns, the underlying math, and then writing it out in a way that the computer understands.
So we've gone from a seemingly simple problem to like this whole world of number theory, efficient algorithms, and clean Python code, all in one deep dive.
That's Project Euler for you. It's all about using math and programming together in interesting ways. This problem is just the tip of the iceberg. Who knows what other solutions are out there waiting to be discovered?
And there you have it, another deep dive complete. Until next time.